Hi guys, welcome to today's lesson on standard deviation. My apologies for not being able to attend lessons for the past 3 days. I should be back tomorrow, hopefully. Alright, so without further ado, what we will be doing today, alright, we will be recapping on how to find mean and standard deviation for ungrouped data in a dataset. Then we will extend what we know to find mean and standard deviation for ungrouped data in a frequency table. And finally, we will extend everything to find mean and standard deviation for group data. Now, before we begin, a few notations for you to recall. Okay, first thing first, the mean will always be labeled as this thing called x bar. The reason why it's called an x bar is because there's a bar on top of an x. Standard deviation will be labeled as SD, quite straightforward there. Elements in the data set will be labeled as X in the formula, but of course, the question itself can use other variables such as t to mean time and so on. And the number of elements in the data set is known as n. Alright, now to recap the formula, the mean x bar, okay, in case you all don't know what this sigma symbol means, this is actually sum of. So x bar, the mean, to find mean, you just have to take the sum of all the data in the data set, so sum of x, divided by n, which is the total number of elements in the data set. To find standard deviation, we've established that standard deviation is simply to measure the distance from each data set to the mean itself, and we've also established why it's squared and square root in the previous lesson. Okay, so this is the formula to find standard deviation itself. Now, there is another formula to find standard deviation, okay, given by this. Okay, so the difference here is that in this case we are talking about the sum of x squared. So x squared is every single data in the data set squared. So this basically means the sum of all the data in the data set squared divided by n. And this is different from this first term. This term itself basically means the mean squared. Alright, now I'm not going to go into details as to why there's another formula. Okay, I'm not going to show you how to derive this formula itself. If you're interested to know, okay, you can just WhatsApp me directly and I will explain to you how this is derived from this first formula itself. The more important thing to note is that this formula, why is it there? It's because it's easier to actually use this formula, and we'll be using this formula most of the time rather than this first formula. Okay, as well as the fact that this formula is given in your O-level formula sheet, so we'll be focusing mostly on this formula itself. Okay, but this formula came from this formula itself. Alright, so now that we have established or rather we have recapped the formula to find mean and standard deviation, okay, perhaps it will be a good time for us to recap on how we apply the formula to find the mean and standard deviation in a given data set. So if you can turn yourself to page 71 and 72, alright, we'll use this question, try 20, to help you recap on how to find mean and standard deviation in an ungrouped data in a data set. Now in this question, okay, the long jump distance of two boys are given as follows. So Ken jumped the following distances, Ravi jumped the following distances. So part A is very straightforward, find mean and standard deviation of Ken's long jump distances. Part B also quite straightforward, find mean and standard deviation of Ravi's long jump distances. Part C is where you need to go an extra step. Remember, we told you that we went through in the previous lessons that comparing mean is basically to see which one does better. So for example, if the mean of class A in a max test is higher than the mean of class B in a max test, then of course class A generally did better. And standard deviation is simply a way to measure consistency. And the key thing to note here is that the lower the standard deviation, the better, or rather the more consistent your results are. Okay, So we will use that to answer part C on discussing the differences between Ken and Ravi's performances. Okay, so without further ado, let's show you how this is done. Okay, or let's go through this together. Alright, so for part A, okay, so to find the mean of Ken's long jump distances, I've actually put the formula here for us to make an easy reference. So what we can do is, um, so let's do part A. Alright, so to find mean, okay, this will take some time. Alright, what we can do is basically the summation of all x divided by n. So we have 6.9. Let's just copy this and paste here. So design fraction. Alright, so summation of all x. So 6.9 plus 6.3 plus 7.3 plus 5.9 plus 7.1, and n is the number of elements in the data set. So we have 1, 2, 3, 4, 5. We have 5 elements. So what we will get will be x bar will be equals to, so if we type this out into the calculator, we should get 6.3 plus 6.9 plus 7.3 plus 5.9 plus 7.1 divided by 5. We should get 6.7 meters. Alright, so this is the mean of Ken's long jump distance. Alright, so to find standard deviation, we'll be using the second formula itself. Okay, so the best way to use this formula is to actually write down everything in a table. Alright, so let's just do a table here. Now the first row we should put in will be our x itself. So x will be 6.9, 6.3, 7.3, 5.9, and 7.1. Now because we need the sum of x square, so we'll just use here x square, and we'll square each of the number itself. So 6.9 square will give you 47.61. 6.3 square will give you 39.69. 7.3 square will give you 53.29. 5.9 square will give you 34.81, and 7.1 square will give you 50.41. Alright, so what we will do next after we have found x square is of course to find each of the things that we need to calculate to find standard deviation. So over here we need to find the sum of x square. So let's use the formula itself. So sum of x square. So what you will do is you will basically add everything up together. So you have 47.61 plus 39.69 plus 53.29 plus 34.81 plus 50.41. Alright, and you should get, so let's copy this, 47.61 plus 39.69, 3.29 plus 34.81 plus 50.41, and you get 225.81. Alright, so to find standard deviation, okay, let's just copy the formula here. Oops. Alright, to find standard deviation, okay, let's just plug and play everything. So we will have sum of x squared. So this itself is given by 225.81, n is 5, and this itself, like I said, it was the mean, so just plug in 6.7 square, and if I calculate everything, I should get square root 225.81 divided by 5 minus 6.7 square. 0.52522. Alright, so round off to 3 SF. Alright, so we can now conclude that the mean of Ken's long jump distance is 6.7 meters, and the standard deviation of Ken's long jump distance is 0.522 meters. So the unit for standard deviation and mean is the same as the unit for your data itself. Alright? So part B, find the mean and standard deviation of Ravi's long jump distance. So just to make things easier, let's just copy and paste this itself below. So part B, I need to find the mean and standard deviation of this. So let's do the same exact thing. So to find mean itself, we will calculate the x bar. So let's just calculate the x bar. Let's just change this into 7.2 plus 6.7 plus 6.4 plus 6.9 plus 6.3. Alright, so what will we get? 7.2 plus 6.7 plus 6.4 plus 6.9 plus 6.3 divided by 5, and I will get 6.7 meters as well. Oh wow, okay, that I really did not expect that. Okay, so the mean for Ravi's jump and Ken's jump is actually the same. Okay, so let's leave it as such. Okay, so for standard deviation, same thing. Okay, we will be calculating using the same way as we did for part A. Okay, so same thing. Okay, I will have to change all the numbers here. So 7.2, 6.7, 6.4, 6.9, 6.3. Alright, so square each number. So 7.2 square will get me 51.84. 6.7 square will get me 44.89. 6.4 square will get me 40.96. 6.9 square will get me 47.61, and 6.3 square will get me 39.69. Okay, and then we will do the same exact thing as what we did in part A. So we will first find the summation of all the x square itself. So let's just calculate out the summation of x square. So we will have 51.84 plus 44.89 plus 40.96 plus 47.61 plus 39.69. Alright, so if I was to add all of them up together, we will get 224.99. Alright, so same thing, we'll substitute the summation of x squared into the formula here. So this should get me 224.99. N is still 5. The mean is still the same. So if we were to calculate everything, we will get ourselves give me a moment. To 4.99, we will get 0.329. So we can now conclude that Ravi's mean, or the mean of Ravi's long jump distance is 6.7 meters. which is the same as Kent's, and the standard deviation of Ravi's long jump distance is 0.329 meters. Again, we round off to the nearest three significant figures. Alright, now the next part, okay, if we go back to the question, is to discuss the difference between Ken's and Ravi's performances. Alright, so let's just copy our answers from part A so that you can compare them side by side. Alright, so the mean here and for Ravi here. Now, if the question was to just ask you to discuss Ken's and Ravi's performances and they never specify differences, then you will have to compare the mean. So if let's say the question tells you to discuss the performances without specifically saying differences, we will have concluded that both Ken and Ravi perform similarly, alright, because their mean is the same. But since we are talking about the differences, what we can see is the fact that Ken's standard deviation 0.522 is actually higher than the standard deviation of Ravi's long jump distance, which is 0.329. So we can say that because Ravi's standard deviation is smaller, Ken's standard deviation is higher, we can conclude that Ravi is more consistent. So we will write down there, Ravi is more consistent in his long jump than Ken. Of course, you cannot just give the statement, you must give the reason. So because the standard deviation of Ravi's long jump is lower than the standard deviation of Ken's long jump. Right? And so there we have it. So this should be our final answer itself. Alright? So just to quickly recap again, to find mean is quite straightforward. You guys have done this since Sec 1, since primary school in fact. The only difference is to find standard deviation. Now if we were to use whether or not we use the second or third formula, it does not matter, because the best way to do this, to approach this question, is to actually draw out a table. So we have x squared. So you square every single data set, and then you'll find the summation of x squared itself, and then you just substitute it into the formula of this standard deviation. Alright, so best tip I can give you right now to find standard deviation, draw a table. Alright, so that concludes our recap itself. Okay, so I hope you guys still remember how to find the mean and standard deviation. I hope you guys understand what's happening. Alright, now what if instead of a data set, the question, or rather the data that we are interested in, has been put into a frequency table, something like try 22 itself. So let's turn ourselves to page 71 and 72. So in try 22, okay, instead of a data set, the question has actually given you a frequency table to represent the data itself. So let's look at the question. The following table shows the distribution of the number of goals scored by a football team in 30 matches. So we have a frequency table here. Find the mean and standard deviation of the distribution. I'm going to ignore this part first, okay, but let's just look at this table itself. Alright, now before we can talk about the formula itself, perhaps it's best to understand what the frequency table actually means. Alright, so in this case, what you must understand is that when I say that the number of goals is 0 and the frequency is 5, that means that there are 5 matches where the goals are 0. And there are 12 matches where the goal is 1, there are 8 matches where the goal is 2, and there are 4 matches where the goal is 3, and there's 1 match where the goal is 4. So if I was to represent this in a data set, we would probably get something like this. 0 5 times, 1 12 times, and so on and so on and so forth. I'm not going to write down the whole thing because it's very tedious, because you will have 30 elements inside the data set. Alright, but there is a shorter way to do this. Alright, you realize that if I want to find the mean of this, alright, if let's say I want to find the mean, which is this, alright, I can go the long way. I can put there 0 plus 0 plus 0 plus 0 plus 0 5 times, 1 plus 1 plus 1, and so on. Or I can easily do this. 0 times 5 plus 1 times 12 plus 2 times 8 plus 3 times 4 plus 4 times 1 divided by, of course, my frequency itself, 5, 12, 18, 4, 1. So in fact, you don't even have to write down this. You can write down 30 straight away because it's already given in the question, 30 matches. But just for the sake of it, let's just write down 5 plus 12 plus 8 plus 4 plus 1. Now, you realize that what I am doing over here, alright, I am actually taking each of the number of goals, so number of goals, and I am actually multiplying the frequency of the number of goals itself, so times frequency, and then I will sum it all up. So let's just put summation. Where is my summation? Okay, it's here. And over here, I am basically adding up all my frequency. So what I can put here. So essentially what happens is that I can actually generalize this into a formula where instead of just adding up 0 plus 0 plus 0 plus 0, I can take the number of goals 0 multiplied by the frequency plus the second number of goals 1 multiplied by the number of frequency, and so on. Alright, so to extend what we know itself, okay, instead of dealing with individual data in the data set, we can actually simplify our equation to include in frequency inside it. Okay, so before we talk about the formula itself, okay, there's a slight change in the notation that we have. So instead of the total number of elements in the data set, we are going to be using F to represent frequency. Alright, so as shown earlier, okay, we can actually simplify our formula to this thing itself. So the mean itself is the sum of each x multiplied by the frequency. So this x is not the individual data in the data set. This x represents each of the data that correspond, each of the data in the table, okay, and then divided by the sum of frequency. Now, if we look back to the previous formula, alright, here we will have x minus x bar squared. So what we can do instead, we can easily multiply by f. Okay, now there's an error here, I'm so sorry. Okay, this should not be n, this should be the sum of f. Alright, and of course we can also extend the data, or sorry, we can extend the formula to the one that is actually going to appear in your formula sheet itself, which is this. Alright, so instead of having just x squared, we will multiply each x by f, okay, and we will get this thing itself. So how can we apply the formula to this particular equation? Alright, so let's just copy this first. So let's apply this thing itself. So for the mean, it's quite straightforward. Okay, as shown uh, in the previous page. Okay, we just take each number of goals multiplied by the frequency, and we will have, oops, x bar. So again, x bar, where's my accent? X bar equals to, so just calculate everything inside. So we have 0 times 5 plus 1 times 12 plus 2 times 8 plus 3 times 4 plus 4 times 1, and divided by 30. So you have altogether 1.466666. So 1, or rather, if you want to change it to fraction, we have 1 7 over 15 goals. Alright, so that's quite straightforward, I guess. Now, that's for x bar. To find the standard deviation itself, okay, same like the previous example, okay, we will be using a table. So we'll just copy the same exact table that we have given in the question, okay, but we will add a few more rows to it. Alright, so what we will do, again, I need my x square, so I'll just put a new formula over here. So I will have x square. So x square simply means 0 square, which is 0. Okay, maybe I should make the column wider. Alright, 1 square is simply 1, 2 square is 4, 3 square is 9, and 4 square, whoops, is 16. Alright, so we will have this table with x square, but because we are dealing with frequency, and you realize that we have fx square here instead of just x square, so what we will do is we will create one more column, one more row for fx square. So over here we will just take each of the x square multiplied by the frequency. So here I have 0 times 5, which is still 0. Oh, I still need to widen my column. Sorry. Let's just put 3 lah. Alright. And here I will have 1 times 12, so which is 12. Here I will have x squared, which is 4, multiply by the frequency, which is 8, so I have 32. Here I will have x squared, which is 9, multiply by the frequency, which is 4, so it's 36. And here I will have 16, and the frequency is 1, so it's still 16. Alright, and similar to the ungrouped data in the data set, alright, before we find the whole standard deviation thing, alright, always make it a habit to do this. Sum of fx squared equals to 0 plus 12 plus 32 plus 36 plus 16, alright, and I will have 96. And then from here we'll just simply substitute in everything into the formula. Alright, so we have this formula. So fx squared, the sum of x squared is already given by 96, so let's just change this to 96. Here is given by frequency, which is 30 minus sum of fx squared divided by sum of f. So this is still mean, and the previous mean that we have is given by 1 over 1 7 over 15. So we have 1 7 over 15 square. Alright, So if we calculate this, we will have standard deviation equals to square root 96 over 30 minus 7 over 15 square. And you will have 1.02 as the standard deviation. So now we can conclude that the mean or number of goals scored by the team is equals to this fraction over here, and the standard deviation of goals scored by the team is 1.02 goals, which is again rounded off to 3 significant figures. Honestly speaking, I don't really like to deal with mixed fractions because you tend to type in wrongly into the calculator, but that's beside the point. Alright, so there you have it. Again, we have a table. Again, I show you how to find summation of fx square. Alright, so if you wanted to make it more, not say more nicer lah, if you want to make it more proper, you can easily add in one more row here. Okay, this will be your fx. Okay, so this will be simply 0 times 5 is 0, 1 times 12 is 12, 2 times 8 is 16, 3 times 4 is 12, 4 times 1 is 4. Reason why I do this is because we can actually use this row itself, okay, this row itself, to calculate mean. So instead of having this, we will have 0 plus 12 plus 16 plus 12 plus 4. Or if you want to make it even nicer looking, what you can do is also, you can actually, present your answer as such. So instead of having just x bar like that, we can just put fx equals to 0 plus 12 plus 16 plus 12 plus 4. Alright, and then you have 0 plus 12 is 12, 0 plus 16, 12 plus 12 is 24, 34, 40, 44. So this is 44. So then our x bar itself can simply be 44 divided by 30. Alright. I'm not going to go into more details as to why we have to present it this way. I mean, yes, you can present it like how we presented in the earlier part of the video, okay, but there is a reason why I need to show this. There is a reason, okay. I will let you know the reason towards the end of the video, or rather on Thursday when I'm back, okay. But yeah, so this is what we have here. Okay, again, same thing, we will always have this table itself to help us calculate the standard deviation. So always find x square and then fx square, fx if you want to be more precise, so that you can use this in calculating your mean, and then fx square is used in calculating your standard deviation. And then this itself, always remember this means your mean. So you don't have to write down there 44 divided by 30 again. You can just straight away use your mean, so don't have to do double job here. Alright, so there we have it, how we can actually find the mean and standard deviation of ungrouped data in a frequency table. Alright, so yeah, this is what we have gone through so far. Now, what if instead of a ungrouped data in a frequency table, we give you a group data? Alright, group data and ungrouped data. So this means an ungrouped data where each x is an individual number. But sometimes we don't want to, sometimes we want to group them together. Because if we were to list them out by their individual number, we could end up with, let's say, 30 or 40 columns. Okay, so instead of that, sometimes we want to group our data together. So this basically means group data, all right, where I group everybody that spends between 0 to 2 hours into one column, 2 to 4 hours into one column, 4 to 6 hours in one column, 6 to 8 hours into one column, and 8 to 10 hours into one column. So this is what we call group data. All right. So how exactly can we find the mean and standard deviation of our group data? The problem is that here we have an exact value for x, but over here we don't have any exact value for t. It's a range of numbers. It can be 0, it can be 1, it can be, sorry, it can be 0. It can be 0 0.1, 1, 1.1, 2, which is why I want to highlight the very important keyword in the question itself. If you read the question, find the estimated mean and standard deviation of the amount of time spent watching television programs daily, you realize that the keyword over here is this word estimated. Because what you are going to be doing is you will be applying the same exact method that you used to find the mean and standard deviation in the ungrouped data in the frequency table to find the mean and standard deviation of group data itself. But the reason why it's estimated is because we can't possibly use all numbers. We can't possibly be using 2.1, 2.2. So what we will be doing, alright, okay, first thing first, the formula itself will remain the same except that there's a word estimated in front of everything. Okay, but what we will be doing is this. Alright, so let's go to this as equation itself. So same formula, but this time around, before we do anything, okay, let's just take the table itself. Alright, let's just use the table here. Let's put the table here. Alright, so what we will be doing, the first thing we will do, we'll just put a new column, estimated t. So this estimated t will be used in calculating our mean and standard deviation. And the way you do it is actually quite simple. What you will do will be to take the midpoint. So in this case, the midpoint of 0 and 2 will be 1. The midpoint of 2 and 4 will be 3. The midpoint of 4 and 6 will be 5. 6 and 8 will be 7. And 8 to 10 is 9. Then, of course, similar to how we did our previous questions, we will always have our x square, or in this case t square. So estimated t square will be 1 square, which is 1, 3 square, which is 9, 5 square, which is 25, 7 square, which is 49, and 9 square, which is 81. And this time round, we will just calculate everything out together. So we will have estimated ft. So frequency is f, t is time, because we need this for our mean itself, fx. So in this case, ft, we just take 11 times 1. So 11 times 1, which is 11. Okay, so we need to stretch out our table a bit. So let's just put our width as 4. Nope, not enough. Too much. 3.5. Right. So we will have over here 18 times 3, which is 54. 15 times 5, which is 75. 9 times 7, which is 63. And 7 times 9, which is also 63. Alright. Then we will also need our ft square. So same thing, estimated ft square. Oops, italics. So same thing, we will just take 11 times 1, which is 11, So now we are looking at these two columns here, these two rows, this estimated d-square and the frequency. So here is 9, so 9 times 18. So we have 18 times 9, which is equals to 162. Here we will have d-square is 25, frequency is 15. So we will have 15 times 25 equals to 375. Here same thing, frequency is 9, t square is 49, so we have 9 times 49 equals to 441. Oops. And here I will have 7 times 81. Oops. Equals to 567. Alright, so I will always be drawing out the table whenever I want to calculate standard deviation because it makes things very neat and tidy. Now we will need our summation of fx, we need summation of f, we need summation of fx square. So let's go through one by one. So summation of fx is simply given by sorry, in this case it's not fx, it's ft. Oops. Is given by 11 plus 54 plus 75 plus 63 plus 63. Am I correct? 11, 54, 75, 63. Yep, I'm correct. So I will have this equals to 266. And then we will also have summation of f. Do note that sometimes, okay, if we go back to the question itself, oops, okay, you have always this starting line, and you realize, especially this part here, this actually gives you the summation of f. So don't have to waste time calculating the frequency itself, 11 plus 18 plus 5, 15 plus 9 plus 7. We can just straight away put summation of f equals to 60 people. Then we will have summation of ft square. So let's put there, summation of ft square is, oops, what happened? Oh, okay. Equals to 11 plus 162 plus 375 plus 441 plus 567, and we will have summation of ft square equals to 1556. Alright, so then what's left is to find the mean and standard deviation. So what we can do is, again, estimated mean, not just mean. Okay, sorry, estimated mean is given by summation of fx over summation of f. So what we will have will be, so now that you have actually calculated out everything, you realize that you don't have to write down everything again. You can just key in here 266, and summation of f is 60, and you will get equals to 4.43. Alright, quite straightforward. And same thing for standard deviation, okay, or rather estimated standard deviation. We don't have to write down the substitution again because everything is neatly arranged here. So summation of ft square is given by 1556, summation of f is given by 60, and this itself, as I say, is the mean. Okay, actually if you calculate it yourself, it's actually an exact number. It's not a irrational number, it's actually a rational number. So let's just put the exact fraction itself, 133 over 30. and you will get equals to square root 1556 over 60 minus 133 over 30 square, and you will get 2.51, again rounded off to 3 SF. So now you can answer the question. um, let's just calculate, copy this. Okay, so the estimated mean of the amount of time spent watching television programs daily is 4.43 hours. Then let's copy that again. The estimated standard deviation of the amount of time spent watching television programs daily is 2.51 hours. And there you have it. To calculate the mean and standard deviation for group data itself. Alright, so technically the way you calculate um, the mean and standard deviation, whether or not it's for group data or ungroup data in the frequency table, is actually the same exact formula. The only difference is that there's an additional word called estimated. Okay, so this again will be given in your formula sheet. I can't really recall whether this is given in the formula sheet, but I mean it's easy to remember, so let's not think about it so much. Okay, so now one of the things that you realize with this particular chapter, especially this particular part about finding standard deviation, is that it is very tedious. I mean, it took us about 45 minutes to go through all this. It took out about 15 minutes worth of typing into calculator. So there is a much shorter way to find all these values. In fact, technically what you need to show in your working is this exact part over here. Okay, this is what you need to show. This part itself, okay, is really for your own reference, especially if you don't do the shortcut method, or if you can't remember how to do the shortcut method, because there is a shorter way. The difference, or rather the problem with the shorter way, is the fact that it's quite complicated to remember the steps because it involves using your calculator itself. So what I'm going to get you to do is very simple. You still need to do this table method. So what you're going to do next, alright, will be to complete right 19, 21, and 23. Alright, and once you have completed right 19, 21, and 23 using the table method, okay, you can actually look after try 23 if I remember correctly, or before try 23, that there is a section in the textbook on the calculator method itself. Okay, so what I'm going to get you to do is to read through the steps there. Okay, it's very it makes life easier, but to remember the steps is quite um, hard. Okay, so it's either you want to have a tedious way of writing it down, or you want to have a tedious way of typing the calculator. um, but basically this is what I'm looking for. This part of the working is what I'm looking for. Alright, so do these questions first, and tomorrow when I'm back I will go through these questions with you guys, and I will also show you the calculator method itself. Alright, so yeah, have a nice day everyone. 谢谢。